Okay, well, on the last page of the review, problem number 13 says to sketch the top, front, and side views for the hat rack shown. The front view is looking this direction right here. The top would be if you're standing over it and looking down, obviously. And the side is looking from this side in this direction. And so let's sketch the top first, the top view. If you were standing above this hat rack and looking straight down, you would see this rectangle. So I'll sketch that first. And then these two pegs that are coming out of the hat rack that you hang your hat on, from the top view as you're looking down, would just look like rectangles. No part of that circular face would be showing. You just see a vertical line here. The front view would be looking this direction, straight at this, so you'd see this back piece, this large rectangle. And that's where you would see these two circular faces in this front view only. You would see these two little circular pegs. The side view, looking from this side, is indicated here. You would see again this back plate that would attach to the wall. And then you'd see, since these pegs are likely centered on this board, while there are two of them, you would only see one. You'd see one of those sticking out, and it would, again, from that view, it would look like a rectangle. You wouldn't know that there's a circular face from this side view, only from the front view. So I think the side view would look something like this. Okay. Problem 14 asks us to calculate the volume of the solid shown below and round our final answer to the nearest tenth. So what is this solid? It has a single base, this rectangular base, and then all of these other faces are isosceles triangles. It comes to a single vertex. It has one base. This is a pyramid, and since the shape of the base is a rectangle, it's a rectangular pyramid. The formula for volume for any pyramid is very similar to the formula for volume of a prism, but you can see that if this was a rectangular prism, it would be taking up a lot more space. The volume of a pyramid or a cone is 1/3 the volume of a prism with the same base, shape, and height. And so it's 1/3 area of the base multiplied by the height. Now, this is one of the most common mistakes on this test, is to forget the 1/3. But you know I'm going to either give you a pyramid of some type or a cone, so don't forget the 1/3. It's in your formulas. If you just realize what you're looking at, think about what shape you're dealing with, and use the formulas, you'll be in good shape there. Area of the base will be area of this rectangle, so base times height. Area of the base is going to be 38 multiplied by 11, which is 380 and 38, or 418 meters squared. And the height of the pyramid is just the perpendicular distance from the vertex to the base. Just like the height of a triangle is the perpendicular distance from the vertex to the base. So the height is 10. So I can substitute into this volume formula. Now we have 1/3 of 418 multiplied by 10. 418 isn't divisible by 3 because 4 plus 8 is 12, and this extra 1 makes 13. So I'm just going to do 1/3 of this product, 4,180. And on your calculator, you would just do 4,180 divided by 3. You're going to get 1,393.333. The 3's go on forever. We're rounding to the nearest tenth, so identify the digit in the tenths place. Is the digit in the place value to the right of that 5 or more? It is not, and so you just leave it as 1,393 3/10 meters cubed for volume. Volume is how many cubic meters will fit inside of this pyramid. Volume is 3-dimensional measurement. Lastly, we have problem 15. A cylindrical glass vase is 6 inches in diameter and 12 inches tall. There are 3 inches of sand in the vase as shown. What is the exact volume of sand in the vase? So, given the question that's being asked, we really don't care that the vase is 12 inches tall. It's not asking me for the volume of the vase. It's asking me for the volume of sand in the vase. And so really the height we're interested in is this 3-inch height. You can see that the sand takes the shape of the vase. And so really we're just trying to find the volume of this cylinder of sand, this sand cylinder, which has a height of 3 and a diameter of 6. Volume for any prism or cylinder is area of the base multiplied by the height. Area of the base, since this since we're dealing with a cylinder, has a circular base, and so the area of the base is pi r squared. It hasn't specified. Oh, it has specified. This is another thing about this problem that you need to be looking out for. You may wonder, what should I use for pi? It says the exact volume of sand. And so you can't substitute 3 or 3.14. You just need to leave pi, let pi be pi. That's the only exact representation of pi, is the symbol pi. That's why it's given a symbol. The diameter is 6, so the radius is 3. So pi multiplied by 3 squared is the area of the base, which is pi multiplied by 9, which is better expressed as 9 pi. Okay, so big B is 9 pi, area of the base is 9 pi. Now we can substitute into the volume formula. Volume is equal to 9 pi multiplied by the height of the sand in the cylinder, which is 3 inches. And you can't do anything with pi except leave it pi, so you associate the 9 and the 3. 9 times 3 is 27. So 27 pi is the exact volume. And then you just need the units, which are inches cubed for volume. 27 pi inches cubed. Had the question asked us for, let's say it asked how much more space could you fill up in the vase, then you would take the volume of the whole cylinder, in which case the 12 would matter, and you would subtract this volume. And you get you could think of it as a cylinder of air in the vase right now. That's just would be a different type of problem, but another one that you might be asked, something like that. Okay, I hope that helped with the review. I'll see you tomorrow. Thanks for studying for your test.